guys, I am Alferos from EC31 and I am here to present my Midterm Summative Assessment 1 in Digital Electronics 2. Simple application of digital input and output using PIC16 F1 8875. So before that, let us first open our MPLAB XIDE. Go to File, yung project, then standalone project, okay, let's wait for some. Okay, there. So let us search our device, which is the PIC16 F1 8875. There you go. Then click next. And after that, our compiler will appear. Then let us name this as SA1 and finish. Okay, let's wait for some moment. By the way, I am sorry for this type of recording since I am using my phone because my laptop recording is not that so good. That is why it is much practical to use this phone. So I'm sorry for that. Okay, let's just wait for some time. Generating make files. There. So let's go to Tools, Embedded, and our MPLAB Code Configurator. So MCC Classic. So there, after waiting for some time, we're going to change the package, of course, to PDI P40 for this to be there. The same with our microchip. In port A, we are going to use 4 output pins. This, and this. And for the other 4 LEDs, we are going to mark this, and this. And of course, since there is a switch, we are going to, where is that? There. This 0, then over here at port C. So our oscillator select is alright, internal clock alright, clock divider alright, and there, low voltage programming enable. And for the pin module, we are going to uncheck this column. There. Then we are going to click this WPU. Then renaming the ports with the word what they call it? LED. And the last part is that we are going to mark this as switch. There. So let us generate now. Then on project, we are here on the summative one, and we are going to locate our source file there. Then main C file there, and then there is a while here, and we are going to input. After almost 2 hours of configuring the code and my mistakes I have realized, then we are now going to build it. Okay, after a total time of 49 seconds, our build is successfully, and now we are going to connect our IC in the ticket. So we are now in the MPLAB X IPE, but before proceeding to that, we have first connected the circuit, and let's discuss a little bit. So the first slot, which is the VPP, will go on the first terminal of the IC. The second terminal, which is the VDD, will go on the 11th slot of the IC. The third one, the VSS or ground, will go to the 12th slot of the IC. The ICSP data will go to the 40th slot, and the ICSP clock will go on the 39th slot. So here we are going to find our device, and now we will connect it. Okay, so the target device was not found, so in order to get rid of this, we are going to advanced mode. Then we are going to enter microchip since it is there, and we will have this additional settings or options. Then we'll go to power, setting the voltage to 3.125. So we're going to on the power target circuit from PK3. Going back to operate, going to browse our hex file and the hex file there. So there is an option, hex file loaded successfully. We're now going to program it. Okay, and after some time of waiting on the programming, I have constructed or made the circuit wherein I used 8 LEDs, wherein the first one is connected to the first LED is connected to the second pin, second LED third pin, third LED fourth pin, and fourth LED fifth pin, whereas the 1, 40, 39, 38, 37, 36, so the last one was connected on the 36th, the 7th one on the 35th, the 6th one on the 34th, and the 6th one, and the 5th one on the 33rd. And all VSS are connected to the ground, both sides, and both sides also of the VDD are connected to the positive of the board. And then also apply the switch wherein we are going to use this. And of course the idea of this is like for the Christmas lights wherein it will light, this will light, but on a pattern wherein not on a single boom, but there is a gap. So let's just try it to really verify what is this. Okay, I'll now put my 5 volt supply, and there it goes. There you go. So with the 250 millisecond delay, we can see that the LEDs are having those delay, and with the use of with LEDs with the resistors, because on the resistors it was connected to the negative terminal of the LED, and the resistor was connected to the ground. And that's it for my summative assessment. For my conclusion, so I can say that the programming is quite difficult, especially me. I encountered a problem. There is something like a code error, but it take an hour or more for me to realize that I must be careful. So yeah, being careful is a must here. So, and also with my device, forgive it for being slow. And for the digital input, it is a digital input detects if a voltage is above or below a specific threshold. If the voltage is higher than some value, the computer will detect the digital input as high, set, or 1. If the voltage is lower than some value, the computer will detect the digital input as low, clear, or 0. So we have seen it here. And also for the digital output, a digital output allows you to control a voltage with a computer. If the computer instructs the output to be high, the output will produce a voltage generally about 5 or 3.3 volts. If the computer constructs the output to be low, it is connected to the ground and produces no voltage. So let us take some time for it to feel it.